Hi everyone, Aryan here from the Academic Success Center. Today we're going to be going over QMS110 Chapter 4. More specifically, we're going to be learning how you can solve a two-variable, two-equation system using the method of elimination. You can see the two equations I'm going to be going over today on your screen. So the first one is y equals 3x minus 1, and the second equation is 6x minus 3y is equal to 12. I would encourage you to really give these two a shot and spend about 5 to 10 minutes at the beginning of the video just so you can see where you're at the beginning of the video, and then go through the rest of the video and you can check your understanding throughout. So with that said, let's move on to some review. So on the screen, you can see the different relationships two lines can have on a 2D plane. So you can see intersecting lines, parallel lines, and coincident lines. Intersecting lines being they have one point of intersection. Parallel lines, they simply never have that point of intersection. They just continuously go on forever. And coincident lines are lines that are simply lying on top of each other, as you can see here. So the number of solutions for each of these relationships, the number of solutions is the number of intersections. You can think of it that way. So as we said, intersecting lines have one point of intersection, therefore one solution. Parallel lines have 0 because they never intersect. And coincident lines have an infinite number of solutions because they are right on top of each other. Therefore, there are an infinite number of points that they share. We also look at the slope and the y-intercept when we're looking at the slope y-intercept format of the equations of these lines. So when we're looking at that, the way we can identify which one is which is through these methods. So when we look at the slope, you notice that intersecting lines have different slopes, hence why they cross over. Parallel lines have the exact same slope, and it is the same with coincident lines. They also have the exact same slope. Therefore, if you look at the slopes and you notice that the slopes are not the same, then you have intersecting lines. Now we look at the y-intercept. So again, like we said, we don't need to look at the y-intercept because for intersecting lines, that is, because we can simply identify them by looking at the slope. However, how we're going to decide whether two lines are parallel or coincident, obviously we can't use the slope because they're the same, but we can use the y-intercept. So parallel lines have different y-intercepts, or b, but coincident lines have the exact same one because they are quite literally right on top of each other. So they cross that y-intercept at the exact same point. So with that out of the way, we can now move on to the steps I'm going to be taking to solve this two-equation, two-variable problem. So the first step is to write both equations in standard form, ax plus by plus c. Second step is to make the coefficient of one variable opposites. And then the third step is to add the equations to eliminate variables and solve for the other variable that is remaining. The fourth step is to substitute answer from step 3 into the original equation and solve for the other remaining variable. And step 5 is to write the solution as an ordered pair in xy and check with the original equations. So once again, now that you've seen these steps, I would again encourage you to give them another shot. If you weren't able to solve them, or if you had some difficulties, see if you can get them now that you know the steps. But now let's move on to the first step. So the first step is to write the equations in standard form. And as you can see, I've written down ax plus by plus c. So from this chapter, we know that is the standard form of the equation of lines in a 2D plane. So the first equation that we look at, we see y equals 3x minus 1. So obviously, that is not quite the same as that. So we're going to have to do some things to it to make it look like that. So I notice I need my x and my y on the same side. So what I'm actually going to do, I'm just going to bring that y to the other side by subtracting y on both sides. So I'm going to have 3x minus 1 minus y, and that will be equal to 0. All right, so I just brought that y to the other side. In other words, I just subtracted y from both sides. Then I noticed that I need to bring that c, that constant, which is my -1, to the other side of the equation. So then I just need to add 1 to both sides. So I would have 3x minus y is equal to 1. And that is my standard form of that line. Now look at the second equation. See 6x minus 3y is equal to 12. That one is good to go. I don't need to make any changes to that one. So we're going to go ahead and move on to the next step. Step 2, which is to make the coefficient of one variable opposites. So the reason for that is we then want to eliminate that variable, right? So I look here and I notice, well, I have 3x and 6x. If I multiply that by 2, I will have 6x and 6x, which are not opposites or the same, but if I multiply by -2, then I will have opposites. I would have -6x and positive 6x. So then I'm just going to multiply this first equation by -2. So -2 times 3x minus y equals 1. Now I just need to multiply it through to every single bit. So -2 times 3, that'll be -6, of course, -6x. -2 times -y, that's going to be positive 2y equals, and then 1 times -2 is -2. So there we go. Now I have that. And now my coefficients are opposites, -6 and 6. And you'll see why we need to do that right here. So in step 3, we add the equations to eliminate the variable and solve for the remaining variable. So like we said, we have -6x plus 2y is equal to -2. And the second equation stayed the same, 6x minus 3y is equal to 12. Now if I just add these two, you will notice something, that the -6x and the 6x just equal 0. So that is how we eliminate one variable. Then I have plus 2y minus 3y. Obviously that's going to be -y. And I have -2 plus 12, which is going to be, of course, positive 10. So now I have -y is equal to 10, but I'm looking for positive y. So how do I solve for y? I just simply multiply both sides by -1. So I have y is equal to -10. So I have now solved for one of the variables, and now we can move on to the fourth step, which is to substitute answer from step 3 into the original equation to solve for other variable. So again, we know y is equal to -10 from that last step, and the original equation I picked was the very original one at the beginning that we had, y equals 3x minus 1. You can use this or the new transformed version that we had, but it doesn't really make any difference. It's just that without the transformations, it's less math and less work for you. So I'm just going to use this one. So I know y is equal to -10. So instead of y, I'm just going to write -10 is equal to 3x minus 1. And now I need to solve for x. So I see that -1, I can bring it over. So I add positive 1 to both sides. So -10 plus 1 is going to be -9 is equal to 3x. And again, I'm looking for positive x, therefore I need to divide by 3 to get rid of that coefficient. So -9 divided by 3 is, of course, -3, which is equal to x. So now I have solved for my second variable, which is x equals -3. I just switch the sides. Now I have both variables x and y, so I can move on to the fifth step, which is to write the solution as an ordered pair in xy and check with original equations. So again, we know x is -3, y is -10, and the other original equation is 6x minus 3y equals 12. Right? So we had two original equations. I used one of them to find x, and now for my check, I need to make sure the answers of x and y match with the other equation, because that point of intersection, they share that, both equations. So let's plug it in. So I have 6 instead of x, I'm just going to plug in -3 minus 3, and in bracket I have y, it's -10, and it is equal to 12. So I can just solve this out. So 6 times -3 is -18. And then -3 times -10 is going to be +30 is equal to 12. And then I can just check, is -18 plus 30 in fact 12? And it is, right? Because you can just do 30 minus 12, and it would in fact give you 18. So I can say that I have in fact gotten the right answer. And that is my check. So now we have some more exercises for you guys. I'm not going to be going through these on this video at least, but go ahead and solve these. So the first system we have, it is 2x plus y equals 7. And the second equation is x minus 2y is equal to 6. And you want to use elimination for these once again. This specific example is actually in another video that we have in the introduction, or rather the review section of a video on 3 variables. that we have posted on the YouTube channel. So if you want specifically how I get the solution, you can go over and check that out. But hopefully by now you've given it a shot, and the final solution for this one is actually 4 minus 1. Now we look at the second system. The first equation of this system is 2x plus 1 is equal to negative 7. And the second equation is 4x is equal to negative 3y plus 3. And hopefully you've given that a shot. The solution for this one will be negative 3, 5. And at the bottom here, you'll see system 3, but you'll notice there are 3 equations in 3 variables, x, y, z. And this is what we call, again, a 3-variable, 3-equation system. And you can actually use a very similar method of the exact same method of elimination, rather, and you just need to make some slight changes to it. I'm not going to provide the solution in this one, but I would encourage you to give it a shot, try to solve it on your own now. And if you have any problems, go ahead and check the video that we have solving this exact example. And in that one, we'll be going over some of the topics in this video as well, just for some review. And we'll give you some more exercises of 3-variable, 3-equation systems as well. So again, make sure to check that out if you were interested. So with that out of the way, we're just going to go over the summary of what we had in this video. So we went over how we were able to solve a 2-variable, 2-equation system. Once again, the first step was to write both of the equations in standard form, ax plus by plus c. So you want the constant on one side, and you want the coefficients and with their respective variables on the other. Second step is to make the coefficient of one variable opposites. So let's say if you have, in this example, we had a 2 and a 6. So let's say we had 2x, 6x. So let's say I want to make it a negative 6x, because that would be the opposite. I would have to multiply the 2x by negative 3. In this example, it was actually 3, I believe, and we multiplied by 2, by negative 2. So the third step is to add the equations to eliminate the variable and solve for the other variable. So again, by just adding the opposite coefficients, we get rid of that whole variable, and we're left with just one variable, and we can just solve that out easily. The fourth step is to substitute answer from step 3 into the original equation to solve for the other variable. Right, so once we do get that first variable in step 3, we can just plug it back into any of the original equations, any one of the 2, and go from there. And the last step is, once we do get the other variable, and again, in our example, that was y, we can go ahead and plug it in. So sorry, in our example, it was actually x that we got second. But yeah, we can go ahead and put it in as an ordered pair, and then we can simply just plug it back into the other original equation that we didn't use here in step 4. And if our answers match, then we're good to go. And we have, in fact, gotten the right answer. So with all that out of the way, I just want to thank you all for watching. Make sure to check out our different social media platforms if you have any questions or support on any courses that are taught here at Ryerson University, more specifically Ted Rogers School of Management. So hope you all have a great day.